Welcome to podcast number 40. I'm calming myself down now because decided to start over. Spoke a little too much Navy on this one. So this last week we were in New Mexico doing some testing, and a couple of things happened. It was interesting. We were asked to take a look at a few things and so on, and it all came out pretty well. Well, while we were driving along, one of the younger techs goes, "Oh, look, Sasquatch." So instead of the Adirondacks, where I kept going hunting for Sasquatch, finding them kinda, and you can see, brought a couple of little Sasquatches back. We found Sasquatch in New Mexico. So, not maintained very well, but as expected. You can't. That's the whole point about the hunt for Sasquatch, right? You hear about how great everything's being maintained, and it's all out there, but you can't find it. So everybody's seen it, everybody knows it, but they can't find it. But one of the other things came up, actually in a LinkedIn post by an associate of mine. I don't mention names because the last rant, of course, went off the rails a little bit. But it wasn't. It was actually, his point was correct. We're seeing an awful lot of stuff that, unfortunately, it's not necessarily the engineers and the experienced vibration analysts, for instance, but it's definitely marketing folks. So, unfortunately, that gets out there, and if you've got people looking at the stuff and they're not particularly experienced, or they have no experience at all, whenever you have a discussion, somebody goes, "Well, I don't understand the squiggly lines," and obviously they're not experienced in it. When the marketing stuff comes out, it becomes an issue. I had the editor of a magazine reach out and just to clarify something, and she goes, "Hey, a large electrical testing company sent these images to me, and I've got a little bit of a problem. It shows people at a solar high energy site, and they're in a panel doing testing with bare hands wearing regular t-shirts." And I look at it and I go, "Wow, don't use that in your magazine, whatever you do." I mean, it even comes down to, it's so bad these days that even I simply do not include people in the pictures that we might take in the field, because somebody might have not have been wearing something right, or or the rules change the next day, or whatever else. So other than pictures like this, where I'm standing with my buddy that we've caught. In any case, so we found Sasquatch. I'm still looking for the other one. I want a statue that size sitting right there in my office. In any case, let's take a look at what I'm talking about. So let's start with the one from the post. I'm sorry, that's a different one. Let's look at the one from the post. Now, if you understand vibration, and like I said, I'm going to attempt to be calm this time around, because I laid a few F-bombs and stuff like that in the last one. Your vibration transducer is supposed to be right over the bearing, because how are you measuring the movement of the rotor inside the motor by putting it over a hollow piece of material? So people were arguing, and I go, why are they arguing? This is a bell. All you're going to get is resonance. You're not going to get a true measurement. How can you get a true measurement? I mean, you'd have to cut a piece in here and somehow get a post down to just above the bearing. There was some other stuff having to do with triacs and stuff like that, and I agree. I mean, how are you going to get a triacs reading from there? And I actually have an example of some, and this is an applied situation, probably from looking at some of the marketing photos that are getting out, which I just, and it's so bad that I remember when I worked for one company, we went out and bid on a project, and we were taking 5 position measurements. So, horizontal, vertical, front and back, and one axial. So 5 points on the motor, and then similar on the pumps and other equipment, right? So we're quoting like 5 points on a machine. And we lost the bid, so we were asked to come out because the company that was brought in missed several major issues and that shut down the plant. And the locations where they were taking the data was an X in the middle of the motor. So 1 point. Well, of course they won the bid because it's taking them 1/5 of the time to collect data. And who knows how they did the settings. But, machine learning and AI does this stuff all the time. And you sit down and you read a textbook and you get the formulas together and you create a little software and then you don't care where anything's placed, right? Well, if you wonder why they're not accurate, now you know. So let's take a look at some advertising pieces I saw coming out. I'm missing one. But let's take a look at this one here. Okay. Obviously, this was, edited on here, but how many times have you seen somebody place a vibration transducer on a drum? I mean, a fan cover. Well, I've seen it enough. But what really got me, when marketing is out of control, is when you see something like this. And I blurred out the stuff associated with the company because this just happens to be the ones that I got my hands on quickly. But seriously, you're going to take vibration on your and if you're going to argue with me about this, I'm just going to laugh at you. I mean, be perfectly blunt. If you think that putting a vibration and a vibration transducer on the chuck of a lathe is somehow a legitimate location, then you're the problem. So we have this, and I'll calm down again. We have this stuff going on, and I'll show you. I was asked to do vibration on this. It's like, and I took some other machines at this location. Actually, I'm going to use this as an example next week at the Vibration Institute meeting. So next week, I'm doing that whole presentation. I'm going to talk about that in a second. This is where I'm taking horizontal readings right now, front and back, with the empath, the system I'm using for it. We had already taken the electrical signature data. I'm going to show you that, as a matter of fact, on this machine. So we're taking the data and I had already said, I don't know why you have us doing this. Well, because we want to see this and that. Well, who told you to take data on a Babbitt-style bearing like this to get any type of accuracy? And they told me. And I kind of chuckled. And I said, well, how? Because all you're doing is taking a measurement of the housing around the rotor that is riding on a film of oil. There's no anything that's going to transfer that data. Matter of fact, the markings for where the vibration data was being taken were also on the vertical top point, not just the side. And I'm like, if you're going to take data on this with an accelerometer, you actually have to come underneath. Why? Because that's where the rotor is going to be closest to the Babbitt housing, and then you've got to transfer them through a structure and then out to the accelerometer. That sounds complex. Well, it is. But I see this stuff happening all the time. I've taken data like that before because people insist on it, but I'll take the data and then I rely on my electrical signature analysis. The only time I'll take data otherwise in something like this is with the Hall effect. The vibration transducer might give me an idea of what's going on, but I'm not actually measuring anything real. I mean, this thing was vibrating. I'm getting 0.00 something, right? Good alignment and everything else because they were thinking there's an issue here. And we're going to cover some of that in a minute and how it's calculated. So I come in and I take a look at this. A 720 RPM machine, under load and so on. So this is the application here. So they see a problem going on in one of the bearings on the slow speed, the bull gear. So okay, great. So we'll take a look at that. But the placement. Let's take a look at something here. And the name of this video, by the way, is Motor Go Boom. And there's a reason for it. Let me just jog it forward just a bit. So I can show you something here. Well, you know what? I'm just going to play it. So hopefully this comes out okay. So the motor I'm going to show you, they did the same thing. They put the transducer, elsewhere on the machine. The big argument went on about the fact that supposedly there was nothing wrong with the motor. The vibration equipment said there was nothing wrong with the motor. We said there was something wrong with the motor. So everybody comes into the repair shop to prove me wrong. Vibration transducer back here glued to the motor. So we started up, and as soon as we hit 460 volts, that snap was flame shooting out the connection box. We're staying around. So this motor passed this machine learning vibration system. Well, what I like to do when something like this occurs is pull the motor apart. And let's take a look and see what we see. Looks like things are lagging on me, so obviously I'm taking up way too much. So the rotor scraped the stator, pulled copper out, blew up. Apparently it might have been doing that in place based on what the bearings looked like. Let's pause this because the video is not catching up. Let's take a look at these bearings. Okay, so this passed. This passed. This passed. This passed. Matter of fact, it was green. So when I start taking a look at the whole thing, again, that's my problem. People will sit down with no experience whatsoever, design these things, and then come back and with no experience say, these are the conditions and everything else. It's almost like, next week I'm going to be at the Vibration Institute annual training. On Thursday between 1 and 2 p.m., I'm going to talk about the 2 years of research we did on converting vibration data over to energy data and a rough approximation so that you can get an idea of, the KPI concept that I've been pushing forward since, the early 1990s on energy and emissions related to maintenance, right? Like, how do I get in front? I mean, heck, last week I ended up in front of the plant manager again. Well, you're losing this much energy. Okay, great. And it's having this impact on emissions. Well, of course, that the particular folks, they had a particular view, but and that view was, not exactly in line with the corporate view, but the corporate view was, we were going to meet some emissions goal by a certain date. So I'm showing, if you do this and you do this, you're going to reduce this much energy and so on, and that has a direct impact on your emissions. And they liked that. Why people fight that, I don't know, but they fight it and then they do it. One day, a vibration company is saying, oh, yeah, we figured out how Howard's doing it. As a matter of fact, apparently they use my name a lot. And I don't mind that people do that, but I walked up and one of their folks was showing me a 1 horsepower with a minor bearing issue and trying to explain to me how that was costing 20,000 kilowatt hours per year. And of course, about 15 or 16 tons of CO2. And I said, wow, that's interesting. Because a 1 horsepower motor is 0.746 horsepower, and there are only 8,760 hours in a year. And if I stalled the motor, I would only double the kilowatts. So stalling the motor, assuming it doesn't burn up and it stays stalled for an entire year, would only ever come up with 1.5 times 8,760, or somewhere around 14,000. But that would be a motor that's completely shot. So a bearing usually is a very small percentage of the actual thing. And now it's a constant, meaning that if I have 5 watts of loss on a bearing, regardless of load, it's going to be 5 watts, unless I'm varying speed. Then the friction changes. But to put it into perspective, I did a 500 horsepower DC motor with an obviously shot bearing, and the maximum we had was about 5 kilowatts loss, right? Small percentage. So when I saw that and they're telling me that, I knew they just went, just made up a number. So I said, well, I can't have, but and in the end result of that kind of crap, that kind of scam, is that people then don't use that approach because, magic numbers, right? Then it becomes just the same as saying, oh, whatever else. But, marketing, just like the vibration transducers I just showed you, has this wonderful, wonderful way of misleading like freaking crazy and putting this crap out in the field. So I'm looking forward to my presentation next week. Which leads to another thing. I've had a number of people ask me for copies of the paper that I've assigned a copyright to the conference. And I said, if you want to know the paper and you want to know the formula, because the formula is not in the paper, it's going to be in the presentation. You need to go to the conference. I'm not spending, because it's cost me tens of thousands of dollars to do the study, to have some person sit out there and want me to just give it to them for free. I'm going to present the stuff. You're either going to be watching one of my things or something like that. I'm getting, because if somebody like that gets a hold of it, they're going to sit at their kitchen table, design some piece of crap, and then use my material as part of it, just like this other company. And, I just won't tolerate that anymore. The amount of misinformation getting out there. And you know what? I suppose I don't mind it, because I tell you, I have been busier than ever going around, and a majority of the time looking at this crap and realizing that the misleading stuff that's hitting our companies that are trying to do the right thing, and then the legitimate stuff gets tossed out because the illegitimate crap, and I'm that's my light word, that's being put out there. Machine learning and AI, whee! And I'm sorry, every time I see it in action, well, I don't know, CrowdStrike. Other things, I keep seeing things blowing up. And my favorite is okay, here's one. Yes, we're already doing this with, this technology in wind. And da-da-da-da. It's like, okay, great. Hey, by the way, can you sneak me some data? Because, we only have this, data that we make up in MATLAB to run into. Nobody's actually done this stuff. So, and that just drives me nuts. And there's things that have gone on over the past number of years that are a direct result of my challenging that shit. and I'm done with it. Part of me says just walk away and let people live with the crap that they've decided they want to accept. So, let's take a look at some real data. Not machine learning. Woo! Not machine learning and AI. Some actual... Now, there is some... We use it. I use it all the time. As a matter of fact, some of the calculations I just did, I just wanted to test out ChatGPT. I use it as a tool. There is no way I'm going to rely upon that stuff to do this type of work. Oh my gosh, we're going to have an AI do this over here. Or it's got to train on a bad system, and then anything other than the bad system is considered an alert or alarm. Right? Or, oh my gosh, I'm some guy who read a textbook, therefore I now have experience. That's not how it works. Look, my favorite is the meme that's come out. You look at all these folks at the Olympics, and they've got these glasses on, and they've got this equipment all over, and straps, and they look like cyborgs in order to take a shot. What happened? The guy from Turkey comes up and, shorts, t-shirt, and flip-flops, puts his hand in his pocket and goes poof, and then gets a silver. And people are upset because, oh my gosh, he's not respecting the Olympics, which is a challenge of sportsmanship and capability. It's not supposed to be about any sport. When I was in powerlifting, it was about technology too. But when somebody comes along, he's an expert. If I took somebody who benched 500 in a shirt and somebody who benched raw 500, who is the better athlete? Guy comes along, silver, wow. And it turns out he's been doing that for 14 years like that. So, everybody's all upset at him. Oh, well, too bad. So let's take a look at this. Not machine learning, expert system. Rules built in, by the way, for those folks who try to pull the bullshit about, you need a PhD. Imagine the finger that's supposed to be up. Concept, actual field work with research, rules. Or I could sit down here. Hell, I showed it to somebody once. It took me 10 minutes to create some of the crap that people are using, and it was just as accurate. So, anyways, now that I think I've given you the impression of my thoughts on things, if you want to know how I feel, just ask me. Let's take a look. So this is that machine. I've got, and one of the things about ESA is even through a coupling, even through a belt, and you'll see this in the NIDA article coming up soon, because I do the real world stuff, but you know what? If you want me to show you the math, I can do that too. Here's the math behind how it works. So that stuff's been coming out. Because they're not capable of doing it or understand the technology, they'll challenge those who actually do the work. So I'm taking off the back of an SEL in this case. Well, the result of taking data off of the back of a medium voltage piece of equipment is that you sometimes will get a phase shift. Depends on the accuracy of the CT. So they've got low quality CTs in here, and I'll tell you, there's a lot of things about some applications that I'll comment on. So there's a couple of things, like you'll notice the motor's operating close to 60, not exactly 60 hertz, but this is a pretty significant phase shift here. So the direct result is that I'm a little off here. As long as I stick with that, it's a comparative set of data, it's fine. So I take a look at this, and I can do my calculations from here. Now I'm being told that a certain thing is wrong. I looked at the data and realized that somebody read a textbook somewhere and didn't understand that varying loads on a piece of equipment will vary your vibration readings, my frequency shifts. So I did take a look, and yes, this is this is actually only off about point something percent. It's not much. It's allowed to get down a little bit lower, but they have a generator and everything else in a remote location. So their phase shift off of 60 hertz was pretty significant. We went in and verified it. So if you see this and I hear, and if you want to tell me, oh look, you're not exactly 60 hertz, you're right. It's not exactly 60 hertz. They are not on 60 hertz. They're just off. It's not on a VFD. This is across the line. So it accounts for some of the things we run into here. So the nameplate says 710 RPM. We're going to be all other than 710 RPM. In fact, I wrote it down. We are going to be at 702.8 RPM, which is slower. The direct result, that gives me a running speed of 11.713. I have gears, and the gears, multipliers for the bearing we're going to look at, 10.78, 8.223, 0.44, 0.433, and 3.55. And then this is the high-speed gearbox bearing. In here, 33 and 149, this is the output pinion to the ring gear on the big ball mill. And here's the rest of the data on it. So let's get out of here, and we're going to do something. So when I calculate the data, and I went ahead just for fun, I tested the math on ChatGPT. My frequencies for the inner race, for the output gear, the bull gear bearings, inner race is going to be 27.93. Outer race is 21.32. Cage frequency is 1.12 hertz, and the rollers, because there's twin rollers in these angled, I'm sorry, are 9.22 hertz. So what we're going to do is look for our sidebands and everything around this based upon those multipliers. So this would be 27.93 plus this. So let's just for the sake, we'll start out with so 27 plus 60 would be 87, 88 roughly, minus about 1.5, so about 86.5. So we are going to be right about here. This may be at here, small peak right around 85. And then we're going to go to the opposite side and look for the same thing. And that's going to be roughly about here. So not significant. Next one is going to be 21.32 hertz. So that would be 81 or basically 79. So somewhere in here, maybe this peak. And then also right about here. So I'm not seeing solid peaks coming up that would be high enough to show an issue with these. But I'm going to show you something else that we can actually look and see if there's something going on from a friction standpoint. So 1.12 hertz, that would be close to where these gears are showing. Okay, so this would be 58, so it'd actually be right around the 60 hertz. I don't see that. And 9, so plus 10 basically, so 58 plus 10 would be 68. This one here may be something going on with the rollers. So that gives me a rough idea of what's going on there. Now the software is built, so it's calculating all this stuff already for me. I didn't do it exactly the right way. I should have put it in so that it was showing on the gearbox side. I just tossed the stuff in. Basically, I was checking out the high-speed bearings there and decided I was going to do the other thing for the other. And I could take a look down here at my DMOD, give me an idea of the range and see if something exists. Now, this is obviously the gear because of that shift. But let's go ahead, and what we're going to do is we're going to go to our high-frequency data set, and I'm going to take a look at the watts, figure out the losses. So now I'm reading through a hard coupling at this stuff. I don't have anything significant with the motor. As a matter of fact, motor's brand new. It looks really good. Basically, there's not anything here I'd write home about unless I was looking at certain things. And I'll show you some of that here in a second. So let's go to linear. What we're going to do is we're going to look for those peaks this way. Okay, so I have, let's start from the top. So the output speed, or the inner race, I'm sorry. Inner race is going to be my higher frequency. So is at 27.93. So right about here. So if I come in here, that is going to be 58 watts on a 3,500 horsepower motor. Not too worried about that. 21.93. So somewhere right around here. This could be it, or right before it, but they're about the same height. That's about 79 watts. My cage, 1.12. That's going to be more over here. We'll use this one just because this is something else, I'm sure. But let's say it's this one. We're looking at 891 watts, 1 horsepower worth of losses, turning, that giant bull gear on the cage. So maybe lubrication, maybe something like that. And then the roller, which is right around 9.22, really, maybe up here, so about 200 watts. So not seeing anything particular stick out. The vibration showed something interesting. I said, great, what's the peak view look like? Well, they didn't do that. They did it all in G's. Well, for a slow speed bearing like that, why on earth are you using G's? G's is meant for a higher frequency set. You should be looking at, velocity in this range for bearing related stuff. But what do I know? I've only been doing it for, 30 odd years, 35, 36 years, right? So when I take a look at that, I'm not seeing anything that stands out significantly, even though the recommendation was to do certain things. And, I said, well, here's a simple way to prove it. Get a borescope. Go in and look. Now, one of the other things I wanted to look at was to see what was going on with my RMS current, because I have a very definite gearbox related thing. You can see here the rolling's not much, but this roll right here is obviously the bull gear, just kind of rolling along. So over 48 seconds, that would go along with the speed. I already timed it from peak to peak and came up with the speed, the output speed of the gearbox. So that's these peaks right here. Those two guys are right there. That is the bull gear is not perfectly. I don't think it's perfectly center, or there's something going on with the teeth or something. But we saw that, and it was pretty straightforward. Again, significant enough for me to go in and maybe investigate a little further. But we'll did that in the report to them with our recommendations. So that's about it. Really, they were flagging bearings and everything else, but when I went through it, the bearing losses are not significant enough to start ripping this thing out, except if there's certain other things that I worry about. And oh, by the way, in addition to this going around, like this, you notice that there's very regular impulses here. Those have to do with the gear mesh between the bull gear and the other. So I think I got my point across. I probably pissed off a few people. So sorry, or not really. I'm running into this more and more, and it's really frustrating. There's so many more creative things to do than having to chase after bad applications. biggest thing out there right now, we definitely saw it in the wind industry. All these people, it's the traditional vibration folks. Now, there's a few that are really shining right now, and they do great work. Don't get me wrong. There's definitely a few good ones, and we've gone head to head with them at, so not head to head actually. We're working alongside with certain end users. Like the end users, I remember once we went out to a site and they were like, "Well, our vibration, data isn't seeing this." And so they look and they go, "Oh, well, the settings are wrong." So now all of a sudden we were in line, and vice versa. I mean, there were times when they said, "Hey, our vibration's in," and I'd go, "Oh, well, we just don't have that built into the software yet. Here you go. Here's a way to do it for now," and then we come out with the next iteration of the software with the improvement. So that's kind of it. Next week, I'm going to report out on some of the things we learn at the Vibration Institute. There's, I'm not going to make the workshops just because I have to get some reports out. There are some phenomenal first day, August 6th workshops. I think there's 4 of them. Opted not to do one this year, or didn't submit one this year. I did one on electrical signature last year. It was well attended. I am doing the Thursday presentation on my paper, and I will be, I want to sit in the AI thing, the machine learning one on Friday, just to see what's being said. That's a forewarning. Like I said, I used to teach this. Well, I might have said it in the previous version. I used to teach this stuff. It hasn't changed by much, just the ability to run the stuff on smaller systems. It's got a lot of potential to it. So don't get me wrong. I'm not anti-tech at all. I'm a bleeding edge person. So I'm using machine learning and AI. Problem is, as I showed in those pictures, it's being presented as far more than what it is right now. And I think based on what I'm seeing, it's starting to become obvious. So you should start seeing kind of a step back on a lot of stuff. Investors are going, wait a minute, you mean, this guy says the magic word AI, or what, okay, it's actually machine learning. So machine learning, marketing folks retermed it as AI. It's still machine learning. There's no AI in it. Machine learning. And then to show that they're more advanced than the other guy, they now call it AGI. And in order to get AGI, they had to create something new that was actually AI, called ASI, or Artificial Superintelligence. And now, the same calculators that do that, because AI was always defined as something where, it thought on its own. And I'll be blunt. None of this stuff thinks on its own. Everybody gets amazed. I think it was, the different, softwares that you got on the Amazon thing, Alexa, it sounds like a person speaking to you, and it sounds intelligent, and you can have a conversation with it. That's been around for a while. And then everybody got exposed to a large learning model who they think, it's doing all this stuff that it's not. It's just making best guess on the next thing, on the next word, or, and it can only present you what's in the training data. And I think I've done enough warnings on that. But I just wanted to show you a little bit here. And yes, I used ChatGPT. I just had it. It used to be not accurate for calculations. It's gotten a little bit better. It's early enough in the day that I'm not getting the errors I get by around noontime, which it's getting close to noon now. I did the other stuff earlier on the first, we'll just say, extreme rant attempt. And I just defer to the fact that, sorry, folks, I think somebody got upset. If you're a professional, this, you can't curse. Well, I'm sorry. I work in an environment where my language isn't always appropriate. So with that, have a great time. I'm going to post this one. If I offend some people, then I probably meant to. if you feel guilty about something I'm saying, then have a blast, feel guilty. If you want to say something to me about it, feel free. I'll just laugh at you. Have a great day.